Hello, this is Kartika Aran, Assistant Professor, OG, Department of Information and Technology. I'm going to handle you computer architecture. Code of your computer architecture is 19CS305. Now we are going to discuss about instruction format. We know that instruction consists of multiple bits. So many bits are there in an instruction, but in each and every bit we have the dedicated or same purpose with other bits. That is, all the bits are grouped or categorized into multiple bits. Each and every category or block of bits having some dedicated purpose. For that, I must be knowing instruction formats. It defines the layout of the bit of an instruction. An instruction consists of bits, and these bits are grouped up to make fields. Some fields in the instruction format are as follows: opcode, which tells about the operation to be performed. The second is the address field, designating a memory address or a processor register. The third is the mode field, specifying the way the operand or effective address is determined. Now the next slide is about different types of instruction format. There are four types of instruction format: three address instruction format, two address instruction format, one address instruction format, and zero address instruction formats. We'll see one by one briefly. We saw there is different types of instruction formats. Now we are going to see three address instruction format. Here where three address fields are there, the three fields are address of operand 1, address of operand 2, and address where the result need to be stored. The address of next instruction is held in CPU register, that is called as program counter. Just see the table over here in the slide. For that is add, we have 8 bits. For result address we have 24 bits. For operation 1, that is your operand 1. Okay, operand 1 address is 24 and operand 2 address is 24. For that, the number of bytes to encode an instruction is 10 byte. That is, each address requires 24 bit, which is equal to 3 bytes. Since there are 3 addresses and 1 opcode field, we do this calculation as 3 into 3 plus 1, which is equal to 10 bytes. The memory address required for this instruction is the memory access required for this is 7 words. That is 4 words for instruction fetch, 2 words for operand fetch, and 1 word for result to be placed back in memory. In two address instruction format, we have two addresses and an operation field. The result is stored in either of the operand address, that is, either in address of the first operand or in the address of the second operand. CPU register called program counter, that is PC, contains the address of the next instruction. In one address instruction format, we have one address field and an operation field. This address is of the first operand. The second operand and the results are stored in a CPU register called accumulator register. Since a machine has only one accumulator, it need not be explicitly mentioned in the instruction. This same thing we discussed in other two address instruction format, where a CPU register, that is your program counter, holds the address of the next instruction. Just see, in this scenario we have two extra instructions are required to load and store the accumulator content. Okay, the number of bits required to encode an instruction is 4 bytes. That is, each address requires 24 bits, that is, which is equal to 3 bytes. Since there are one address and one operation code field, we calculate it as 1 into 3 plus 1, which is equal to 4 bytes. The number of memory access required is 3 words, that is 2 words for instruction fetch and 1 word for your operation fetch. Zero address instruction format. Here we use stack. I think we would have learned in your data, you people would have learned in your data structures. What is this stack? is mainly used for the computer which use stack-based CPU organization based on data structure called stack. Okay, the stack is a list of data words. It is also known as LIFO. LIFO means last in, first out. Here two operations are there in stack, that is push operation and pop operation. Push operation is inserting into a stack, and pop operation is deleting it from a stack. We'll see how the stack is related to zero address instruction format. It is mainly used, the stack is mainly used from the CPU for performing arithmetic and logic instruction with no addresses. The operands are pushed onto the stack from memory, and arithmetic logic unit operations are implicitly performed on the top element of the stack, that is TOS, top of the stack. The address of the next instruction is held in a CPU register called program counter. Okay, see the example over here. An addition is performed, that is top of stack in top of stack is equal to top of stack plus second top of stack. This is your addition operation. These are the references. These three books are referred to prepare for this slide. Just refer these books. Thank you. If you have any query or doubt regarding this PPT, you can mail me at kartikaran@savita.ac.in. Thank you.